Hi, this is question 20, and this one has to do with concentration. If you look at it well, you see it has to do with concentration and volume as well. We're trying to get the number of moles present there. So let me chip in something here, because this has become quite important for people that are not too familiar with using your calculators. If you actually go to our website www.copychemistry.com, there's a particular section there where it shows that if you're not so good with using your calculators, you can actually reach out to get some guidance on that, because a lot of people make calculation mistakes and we're helping to actually solve that. All right, so that aside, from question 20 down to question 25, we're going to be working with concentration and volume related questions, because there's no how you solve stoichiometry without going through that part as well. Okay, so are we ready? 20 here is actually quite easy. You're supposed to remember that concentration in moles per liter is equal to the number of moles of solute in moles divided by the volume of solution,
solution
in liters. So I'm emphasizing on the solution here because there's also another formula that has to do with volume of solvent. Not really volume, but kilogram of solvent. And we'll come to that later. But please take note of this. If you want to write it down somewhere, probably put it on the wall or something. I don't know. Concentration equals number of moles divided by volume. So that would come in handy. So it means that if we want to get the number of moles of AgNO3 that's here, we can just say moles is equal to concentration times volume. See that? The concentration is 0.1 molar. That capital M is called molar, M-O-L-A-R, and it's the same thing as mole per liter. Okay, so M-O-L-A-R, or just write capital M, is all mole per liters. So 0.1 mole per liter. And then you want to multiply this by the volume of the solution you're dealing with. How many moles are present in 15 ml of that solution? So the volume of the solution is 15 ml. So we're going to write 15 ml. It's just that we won't write the 15 ml because it's ml, and we need to get that to liters. Okay, so you have, let's just do this apart here. So 15 ml has to be converted to liters. This milliliter, that prefix there, milli, is 10 raised to the power minus 3. Okay, so 15 milliliter is 15 times 10 raised to the power minus 3 times liters. So let's just plug that one in here like this. See that? This cancels this, and then you can do this calculation here, and you should get 0.0015 moles of AgNO3, which you can actually just call 0.02. There's one zero in here, ain't it? Okay. Moles of AgNO3. So that's how to do it. It's just a simple multiplication, but you have to convert at some point. Yes, so that is this. I'll see you on 21. Subscribe and like this post, okay? Bye-bye.